In this video, we're going to solve an additional problem where we differentiate using first principles. In the last video, in order for us to do this, I basically talked about the fundamentals of first principles, where the equation comes from, and all of that stuff. We're not going to go that deep for this question. For this video, the whole purpose is just, we have the formula. Let's just have a shorter, or hopefully a shorter video where I just apply the formula. We have an additional question that you can refer to, and it's more practice essentially. But hopefully this one is going to be a much shorter video, right? So let's just get straight into it. So for this video, we are using the 2023 supplementary exam. If you can hear some noise in my background, hopefully you can ignore that. I apologize for that. What we're trying to solve is trying to differentiate this function using first principles. So what I'm going to do is, right, let's start off by differentiating using basic differentiation, right? So if I have this formula, we know that my differentiation is going to be, I have to take down the 2, so it becomes 2 times 2, which is 4, and then x, and you differentiate the constant, and it gives you nothing, right? So our answer is going to be 4x. So this is going to be the target. So that's the reason why I differentiated using, basic rules of differentiation first, just so that we can have a target and make sure that our answer is correct. So now, let's try to figure this out, right? So we're going to start off by writing our formula. So our first principles formula, in order for us to differentiate f of x, this is going to be f of x plus delta h minus f of x all over x plus delta h minus x. All right, if you want to know where this comes from, the explanation is in the last video, or just make sure that we also write that the limit of delta h tends to 0. Okay, so now let's apply the formula, right? The top part is usually the part that's a little bit more tricky. Essentially, f of x plus delta h means initially, the equation that we were given is f of x. It means that your input was x, right? The moment we now say x plus delta h, it means where you had x before in your equation, replace it with x plus delta h. So instead of, in our formula, so we still have the limit of delta h tends to 0. For this, right, we're going to take this function, but instead of having x, whenever you see an x, replace it with x plus delta h. So this is going to be 2 multiplied by x squared. But remember, instead of x squared, you have x plus delta h squared. And remember, you have to account for x plus delta h as one thing. So we always put it in brackets, right? So that's going to be x plus delta h all squared and then plus 5. So that's your f x plus delta h. And then you subtract f of x. So you subtract this whole expression. Remember, you have to subtract the whole thing. So you're subtracting 2x squared plus 5. All right. So that's the top. The top is done, right? So usually the top is our biggest problem. So you're going to put that over x plus delta h minus x. All right. So we're going to assume these. I'm going to write these at the end. But for now, let's just simplify this. Okay. So to simplify this, you're going to have 2 multiplied by, I'm going to try to do this quickly, but hopefully, this isn't too confusing. So we're going to square this bracket, right? So you can use the FOIL method, whatever method you want to use. But basically, in order for us to square this, you're going to say x times x. This gives you x squared. Then you're going to have x times delta h, which is delta h times x. But that's going to appear twice because it's in both brackets, right? So that's going to be times 2. So that's going to be 2 delta h times x, right? Again, if you want to do the long way, you can go ahead and do that, right? Plus, and then we have delta h times delta h, which is delta h squared. And then that's the end of that bracket. And then you still have the plus 5. And then we still have this one. So now this negative sign, so always be careful about the signs in these questions. So you've got negative multiplied by this, but remember it also multiplies by the positive 5, right? So that's going to be minus 2x squared minus 5, because negative and that positive gives us minus 5, all right? And then this is going to be over, I'm seeing that I'm running out of space. plus delta H minus X. And then this is equal to, so let's simplify, right? So this 2 multiplies into the bracket. So the 2 has to multiply by each and every one of these terms. So that's going to be 2 multiplied by x squared. This gives you 2x squared. 2 multiplied by 2 times delta H, that gives you 4 delta H times X, plus 2 multiplied by delta H squared. This gives you 2 delta H squared. And we still have the plus 5. We still have the minus 2x squared. We still have the minus 5. All over x plus delta H minus X. We're going to encroach over here. So just, ignore this question over here, right? We're going to write below it, right? So at this point now, this is where the fun kind of starts, right? So it starts to get a little bit more satisfying because now we have like terms. Things should start canceling, right? So we can group our like terms at this point. So what I mean by that is we have this 2x squared. We should have another x squared term, which is that one over there, right? So you have a positive 2x squared minus 2x squared. Those are going to cancel out. Same thing with the 5, right? So you have a positive 5, negative 5. Those can cancel. All right, there's no other like terms that we can cancel, so that's perfectly fine. So we're going to write this as, again, just ignore that this, pretend that this isn't there. All right, so that's going to be 4 times delta H X plus 2 times delta H squared over, again, I forgot to do the bottom as well, right? So we have positive X over here, we have negative X over there, and those two should cancel. So at the bottom, what we have left is a delta H, right? So the indicator that you're in the right direction is usually that there is only delta H terms at the top, because now the next step is going to be, we're going to factor out our delta H's. So if you factor out the delta H at the top, you're left with 4x over here because you've removed your delta H, and then plus 2 multiplied by, remember you've taken out one of these delta H's, so you're only left with one of them. And then at the bottom, you have delta H. And those two cancel each other out. One at the top, one at the bottom. So that means the only thing, again, right, we're running out of space again, right? So let's just write this as 4x plus 2 times delta H. But remember, all through here, we were carrying, I don't know if I can actually erase this. I can. Perfect. All right. Oh, can't. Okay. 4x plus 2x. So remember, all this time we were supposed to have a limit of delta H tends to 0. So our limit of delta H is going to tend to 0, which means that H is so small that we can actually just assume that it's 0. So when your 2 multiplies by that 0, this actually goes away. Okay, and the only thing that you have left in your equation is just 4x, and that is our derivative. It's equal to 4x, and then we're going to go back to our target just to make sure that it's correct and it matches. So perfect. Right, so hopefully just the fact that I was writing under these isn't confusing. Obviously, we didn't go through question number 2, which is the tangent question. We didn't go through this one. We were differentiating. Those, will be covered in later videos. The target of these is just to look at the first principles questions. But especially these steps here are where a lot of students get things wrong because there's just a lot that's going on. So just at this point, if you need to work things out on the side, to work them out separately and not together like this, because this does, there's a lot that's going on here, right? So it's a little bit clamped. If you need to do things on the side and then join them at the end, once it's simplified, do so, right? Do what makes you feel comfortable, as long as you don't make mistakes, all right? Because at this stage, mistakes are what, cause students to lose marks. But hopefully this is helpful. And as always, I'll see you in the next video.